Hello, everybody, and welcome to this week's Hubble Hangout. My name is Tony Darnell. I work at the Space Telescope Science Institute, and we have a really great hangout planned for you today. We're going to continue our celebration of the 25 years of Hubble Space Telescope being in orbit, and we are going to show you what we're calling the microsite, which is sort of the central hub of all things Hubble 25. And we're also going to show you 25 of what we consider to be some of the most representative images of not just the science of Hubble, but also some of the images that illustrate some of the beauty of the universe as well. And so with me to talk about that is, as they are with me every week, is Dr. Carol Christian. She's the outreach scientist, and Scott Lewis, Esquire, the third Esquire.
Wow.
It
just every week it keeps going. I love this.
Yeah.
I just call me the Lord of the Internet, and that's fine. No, I'm from knowthecosmos.com.
From knowthecosmos.com. So this week's format's a little bit different because it's just going to be the three of us talking about these things. So we really want you. This is a great chance for you to ask us questions, leave us comments. The best way to do that's with the Q&A app on Google Plus or the video that you're watching this on. I think it's also on YouTube as well, and you can comment on the YouTube channel this is being broadcast on, as well as the Google Plus event page. We're looking at all these things. So I'm already seeing Tony Lynch giving us a hi, and Michael Jobin giving us an exclamation point. So keep them coming, folks, and we'll get to them as we step through the program. So let's get started. So Carol, we are in the process of celebrating the 25 years of the Hubble Space Telescope. And we made this thing called the microsite. Let me share my screen and put it.
Let's show that.
You get to this thing by going to Hubble 25th.
Fifth.
That's so strange.
25th.
Yeah, Hubble25th.org, and this is where we are putting everything that all of our content will be highlighted here on this spot. So it's relatively new. We just went live at the AAS in January, so it's been up about a month and a little bit longer. Mm-hmm. And as you can see, it's right now got a big banner up here. We've got some things along the side that we're going to get to each one of these. But if you're interested in finding out about news, things that are coming up, this is where you would go. On March 7th, there's going to be a symphony orchestra concert in Baltimore. So all of these things are going to be listed here. Our hangout from today is right up here as well. So you would have learned about our hangout from here if you don't subscribe to our stuff. So these are some of the things. And down at the bottom, we have our Flickr stream, and I'm going to come back to this because that's going to be the highlight of most of what we talk about. And then below that, a little bit about the mission itself, right? Just a brief summary of what Hubble is and how it was deployed and when it was launched and all that kind of stuff. And then we have these other things across the top here. We got a tab called Science, and when you click on that, what do you see, Carol? What is this page designed for?
So this page talks about the basic topics of that Hubble covers, and some people are surprised that we actually do solar system science, but we do. And I think everybody knows we do extrasolar planets, and then bread and butter is stars and nebula, galaxies, and then of course the universe. So we cover all of those topics. From the ultraviolet to the infrared, and this is just to introduce the user to some of the science topics that have been covered, highlights of the science topics that have been covered. I knew some of the solar system science, but actually at the AAS we talked through that, and Hubble has really done some exciting things, which it's hard to observe solar system objects with Hubble. It's tricky, but we've done some interesting things. So
yeah, some of our biggest hangouts have been on these topics too. Just last week.
Like the Jupiter, yeah.
Yeah. So and down at the bottom there are links also. There's going to be articles throughout the year as either new press releases come out or new stories come out. So you want to check with these different sections. If you click on some of these links, like this Comet ISON breakup, will take you to Hubble site. So it's a link that goes to Hubble site, and you can read about some of the articles that we have there. So there's a lot. We're going to try and really be as thorough as we can because there's so much Hubble stuff that you can learn about everything going on and what Hubble has done in the various areas. Now, in the terms of extrasolar planets, though, Carol, this is a pretty new area in which Hubble's been contributing, isn't it?
It is, and it wasn't really foreseen that Hubble would produce as much as it did. And the interesting thing is that even before Kepler was launched, Hubble had done a transit. It has looked, of course, famously at the debris disks, and still looking at debris disks from a couple of famous cases, but also there's a lot more going on, getting data from the archive and really picking through it and finding out all the details of debris disks, and then trying to understand the relationship between debris disks and planet formation. And then there have been a few studies of actually atmospheres. So that's a little bit of a preview to what James Webb will be able to do on extrasolar planets, and of course is related to things that other orbiting and ground-based telescopes do regarding extrasolar planets. So
right. So yeah, and so that's just So this is where most of the science will be highlighted. That's the science tab, so you can check all that out. The images area. In April, we're going to be unveiling the actual Hubble anniversary image. Now, we did unveil an image at the AAS, but that was not the image. And are these past Hubble anniversary images, Carol?
Some of them are.
Okay.
Some of them are. Not all, but some are, yeah.
Okay, so that's where we've gathered a lot of those up. There's some videos that are being created. One of our video producers in-house every month is going to be producing a Hubble themed video, and the first one is already created. It's called The Beginning, and you can watch them here. They're also posted on our YouTube page, our YouTube channel. The next one should be out this month soon, so the idea is to put them out once per month. Is it for every month of the year, or just leading up to the anniversary, Carol?
Leading up to the anniversary, and I mean, she's really uncovered some interesting information, but also some interesting people. And she found somebody who's very old, but she found him, and he knew Hubble.
Oh, that'll be great.
So she did get an interview with him. He's like 95 or something. Anyway, she has interviewed some really interesting people in connection with this. She's done a wonderful job on these videos. They're
she really has. They're awesome. So. And yeah, who we're talking about is Maria Estacion. She also does Behind the Web. That's another video series that she's also doing. So so look there to see about all the videos will be posted here as well. There's an Explore section. These are resources, I guess, we got for students and educators. So if you're a teacher and or just a regular astronomy fan, you can get a lot of information here, information about careers, what it's like, meet some of the people there, some of the discoveries. This is a really cool section here with the different images and facts about Hubble. There's a Q&A that questions students have asked over the years. And there's also a misconceptions section. What's this about, Carol? Myths versus reality.
Right. I mean, there's a lot of things that people like. One of the classic ones is.
I haven't read this page yet. Yeah, the Hubble Space Telescope is a manned satellite with astronauts living in research on it as it orbits.
While that might have been a plan a long time ago, no.
Yeah,
I still love that concept art that I've seen for it, where they did show the
well, that was in our first history hangout, remember?
Yeah,
exactly. It was amazing. And then other things, like, I mean, the next one is a common thing, is that Hubble sees better because it's closer. No, it's by the Earth. It orbits the Earth. And some people think that Hubble, they will learn by asking the question that the universe is very vast and Hubble cannot go to a place and take a picture. So it's in orbit around the Earth, and it is controlled from down here, and we point it much as we do ground-based telescopes. And the reason it sees so clearly is because it's above the atmosphere, which causes blurring of images. So there are things like that come up all the time, and so they want to.
NASA has warp drive technology. What? It doesn't have that?
Not yet.
So yeah,
I do, but I'm holding out. Elon Musk and I have been, keeping it under wraps for a while and finding out how we're really going to start doing that.
Yeah, and the final section here that I think is among the most important are where you can learn about things that are going on related to Hubble 25 that are not necessarily around Baltimore or done here in our sorry, I just got a text.
Local universe.
The local universe. Yeah, it'll be all over the place. And so, for example, there's a talk today in San Jose, California, about Hubble 25 years of imaging the cosmos, and our hangout is right here also today. So that's also listed. So and the hangout from yesterday with I did with Frank about his news from Hubble. So all of the events are going to be listed here as they become known. So,
and I know there are people who have decided to, and as we talk about the images, have decided to use the images and make small presentations locally. And it would be great if they would tell us about that, because then we could advertise that on this page, and then people who are local to that museum or library or whatever could go there as well. I know there's these pockets of these things going on that maybe we don't know about. So.
Yeah, now this one looks really cool. If you're going to be in New York on April 30th, Sarah Seeger, Adam Reese, and those guys are going to be giving a talk on Hubble and our altered universe. That looks really good. So anyway, that's the webpage. Check it out if you want to learn about all things Hubble 25 related. And if you have any suggestions or things that you think we should put up, then by all means let us know, and we can say we can try and get some stuff up there. Okay, so I got a quick question here from Sophia Garcia on the Q&A app. Will they still use Hubble when James Webb Space Telescope is launched? These are from students from Waukegan, Illinois.
Yes, so the idea is to have the two telescopes in orbit at the same time, and we do know that the James Webb is scheduled to launch in 2018, so about 3.5 years from now, and we know that as long as all the equipment is working on Hubble, that it will last at least until 2020 and then beyond. So it will have at least 2 years of overlap, and we certainly will keep it operating as long as all the equipment's working. Hubble will continue to work years thereafter. So there may be more than 2 years overlap.
Yeah, and that'll be an extraordinary period where both telescopes are up and operating.
Yes.
So thank you, students from Waukegan. That was awesome. Ashley NL is asking, what is the URL of the site you are showing here? It's blurry and I cannot see the URL. The URL is in the description box of the video you're watching, so that's one place you can look, but it's hubble25th.org. Hubble 25th. Yeah, and Michael.
I've gone ahead and tweeted it out. It's in the comments now in YouTube and Google+. So if you guys are watching this anywhere there, I've made sure it's in the comment section too.
And Michael Jobin says we should say 25th with raspberry. Michael.
Yeah, exactly.
Hubble 25th. There.
Thank you.
Okay. So yeah, well now my screen and now it's all over my webcam and everything else. Yeah. Okay. So all right, let's move to the images themselves. Carol, among others, was in a sort of a committee, I guess, to pick 25 images. Well, Carol, I'll let you decide. I'll let you talk about what were you thinking here.
Yeah, tell us what you did, Carol.
Right.
What did you do to us?
So the idea was that as we were talking about the 25th anniversary, we said, you know, we should have, when people say, give us 25 images or what are the best 25, it's hard to choose the best or most significant or whatever. So we decided to just sit down and pick 25 images that we thought were engaging images, but also represented the science being done with Hubble. Some of them are anniversary images, some of them are just popular objects. So we came up with this list. We argued about it a little bit because there were so many. And this does not mean that any of the other images are not good images. These are just the ones we thought, if you want to make a poster or whatever, that we would concentrate on the descriptions. And in the images area, there is a poster that you could print. If you wanted to make a display of some or all of these, they're print ready, so you can print them and you could mount them in a school or wherever, library. And they're all set and they have captions. So we decided we should do that. We couldn't do that for all the images we've ever released, but we thought we would do 25 for the 25th anniversary. Cool. So that's what they're about. about.
Just real quick, I wanted to mention that I forgot at the top of the Hangout to mention we're also looking at the Hubble Hangout hashtag on Twitter. So if you want to comment that way, you can as well. All right. So Scott, can you? Scott has, because he is an internet driver extraordinaire, has gone through and gathered the images for us so that we can share them with you. And he has organized them in the same way they're done on our Flickr stream. Now, the Flickr stream on Hubble25th.org. I should probably just show you that real fast. It's right here at the bottom of the main page. You go down here at the bottom, and there is a Flickr stream, and you can click on View Photo Stream, and that is what Scott is showing. It is in order of, on the Flickr stream, it's in order of year, starting from 1990 to the present. Just so you know. Okay. So Scott, I've got you embiggened on the screen.
So what we're looking at here, this is the 1990 image of supernova 1987A.
Yeah,
Frank talked about this a little bit at the Hangout yesterday. Carol, do you have any comments on this one?
So 1987A is very interesting because it has been followed for so long, actually, with Hubble. It's pretty fortuitous that we actually were able to observe it for so long. So this image, there are many images of it. So this is just one of the ones which is very interesting. But the idea was that as the explosion occurred, there was a light, there was a material, but there was also light that came out from the supernova, and it ended up lighting up this ring, and over time, different parts of this ring, I mean, at first glance it always looks like a ring, but it has lit up, the light has lit up as it hits from the supernova explosion, hits different parts of it and ionizes different parts of it, and it's very clumpy. So over time, it's actually changed, which is interesting. So this image is evocative of the whole event, but the idea is that we've been watching it over a long period of time. And the ring was actually a surprise because what it indicates, we think of a supernova as being very catastrophic, and what was a little bit of a surprise is that that ring was there. And so as the light came out, before the material came out, but as the light came out from the explosion, it hit this debris that was already around the star. So the star had already done something, maybe not so catastrophic, but it had gotten rid of some material. So the light came out and illuminated that ring, and then slowly over time, some of that material that came from the central star has come out and started to impinge the ring. So it's very interesting, and it's one of the things there. You know, when I first took astronomy, it was always like, oh, things change over a really long period of time and you'll never see changes. And this is one of the things that actually does change quite a lot. So it's.
I know, it blows me away that back in the day we used to think the sky was just sort of static and sort of an unchanging place. But, you know, there's actually fields of study that measure transient events like supernovae eruptions or you're watching, I think, you know, different things rotate up in the sky. So, or one star passing in front of another star and lensing it a little bit. So there's all these little things. It's a very dynamic place, and this is an example of the kind of things that Hubble has discovered that we didn't expect. It's the kind of thing you get from launching missions like this. You find out all kinds of things you didn't even know or didn't even anticipate. So. We're not going to have time to talk about every single image.
Every single one, right?
But
exactly.
I did want to
all of them
very briefly.
Yeah.
So what do you got next, Scott?
I have NGC 4621.
What is that?
From 1991.
Okay.
Well, I just want to know what it is. I can't tell what it is.
And the other thing is we may want to skip ahead a little bit because the thing is that these images are from the early days before the telescope was picked.
Right. Okay. So, all right. So this was an example of an image before the spherical aberration was corrected. Okay. So
right. And so this one's just to give some context about what this image is. It's where we're discovering disk fueling a possible black hole. So there's very early days of Hubble, and yeah, so some things are looking a little fuzzy, and we'll see actually in a couple images the big difference what happened when we were able to fix it.
Yeah, let's go to that. Well, let's go to the next one, and then we'll go to the one you're talking. That's just a real pretty picture there.
This is Orion. Who
Yes.
does? I've got a better one lined up later on in the show.
Yeah,
This is
But
the
this is
Orion
still
Nebula.
prior-
in fact, right after this, we should look at the Orion, because the Orion. So this was one of the first images of the Orion Nebula.
Prior to the repair, right?
Yes, which year is the
92.
92. So
92? Yeah. Anything before 95 is So so this is early, but actually I think it would be a good idea to show if you have one of the mosaics of the Orion. That would be amazing. Do you have? Yes, you do.
We
have
do
it.
have that.
as sort of a before and after thing, you mean?
Yeah, this is So in 2006, let me.
Yeah, maybe.
Pull that up. There we go. Is that showing on the Hangout?
Yeah. So this is a large image of Orion, and it shows a very large region. And this is actually this nebula. Although you're not going to just look up and see it like this. It is a fuzzy spot. If you're at a really dark place. It's part of the nebular region in Orion near the Belt and the Sword, and that whole region has all kinds of star formation and really interesting things. But the Orion Nebula is very famous because it has a lot of structure in it, and there's also
and you can see it with your
3D
naked eye on the dark night.
fly-through of it that was produced.
Yes. Okay, so Scott, while you do the before and after thing, I want to get to a quick question on YouTube. This was from Sergio Montufar. Sorry if I'm messing up your names, guys. Is the Hubble data only available in the Legacy Archive, or is it available in other sites? Where can I download planetary data? Thank you. No, it's not only available in the Legacy Archive. There's also the Mikulski Archive for Space Telescopes, called MAST, which you can do science queries against and get planetary data that way. Is there anything else, Carol?
Well, okay. The Hubble Legacy Archive is an interface into the archive. You can also go to what's called the portal. So if you go to archive.stsci.edu, that's a different interface.
Oh, okay.
So the planetary data should be available through the main archive page, I believe, but I haven't actually tried to search on.
Yeah. Okay.
That. But there's a main archive page, which is where the science data is, and the Hubble Legacy Archive includes that data, but also then a lot of process data as well.
Right. So archive.stsci.edu, and you can also check later. There's going to be a revamped interface for that as well, which we're going to have a hangout on a little bit later once it gets released. So thank you for the question, Sergio. Okay, so
as we move along, I'd like to actually pick some images.
Yes, go right ahead.
So I'm going to kind of throw.
You're going off script, aren't you, Carol?
Yeah, she's going rogue. Before you go rogue,
can I
this is a particular. Sure. This is just a particular list. The list that's actually on the website is different than this, and so I want to make sure that we cover some of the images that we put on this website that have prepared posters.
Okay.
But anyway, go ahead.
So what I wanted to show here, this is actually from 1994, and what's on the Flickr stream is I thought wasn't really indicative of what we're trying to show, but I pulled this up from our press archive. And this is when we're seeing things change. So this is of M100, the galactic nucleus there. And so you can see here on the left what we were seeing beforehand. And then when we were able to put up the Wide Field Planetary Camera 2, we see a huge upgrade in what we're able to see. And this here, I think, really shows on that over 25 years, and this is early on, that we've been able to go up to Hubble and upgrade it and be able to expand what it was originally meant to do, as we'll see later on with frontier fields and things like that. But we've been able to continually improve ourselves in using this fantastic tool we have in low Earth orbit to to get better resolution and to look further back in time and space with Hubble. And so I think this is a really great image that shows that though we might have had some speed bumps in the beginning, we've been able to go up, fix those, and improve them beyond what we were intending to do in the first place.
Okay, so
yeah, I mean that's okay. So that's kind of the turning point at which now the telescope has been really improved. So one of the ones. Another one that I wanted to, before, I don't want to go out into the universe yet. So we've looked at the Orion Nebula. There's one that I think is very interesting, which is the Horsehead Nebula. I'm actually putting that up on my screen, so I guess I can try to I'll screen share.
Okay,
those.
well, while you're screen sharing, I'm going to read a quick question from Pauline Acklin from the Q&A app. She's asking, I've always been curious as to how one is able to rent time using Hubble. What are the qualifications? Does a certain type of research take precedence over another, or is it more independent on who is doing the research? I imagine there's quite a wait list. So the answer to that question is, the short answer is we've done a hangout on this very topic. It's so do a search on our playlist for Hubble Hangouts, and it's called How to Use Hubble. Okay, and we've talked about this exact thing in great detail. But the slightly longer, but not as long as the hangout answer is, we have a committee, a time allocation committee, where proposals are sent, and they are looked at over the course of. Oh, did we lose Carol? And they are looked at over based on a lot of criteria. Mostly their science impact.
Yeah, you lost me for a second too. My app crashed.
Oh, it did.
We're back.
Boy,
okay.
we have.
Well, I'm glad I'm still here. So anyway, that's a good question, and it is a very scientifically fair process. I think, but you're right. It is very competitive. They get way more proposals than they ever have time for. Okay, do you have another? What happened?
Well, I'm having an infrastructure problem. I thought that I clicked on screen share, but it's not.
Okay,
you wanted the Horsehead, right?
Can you just tell,
I wanted the Horsehead Nebula.
The new one?
Yeah.
Yeah.
Okay.
So here's from 2013.
Okay. Yes, this is one of my favorite images. Go ahead, Carol.
So this image, this was interesting because we had done several images of the Horsehead in the past. And so it's the Hubble is a really tiny part of the Horsehead, just right at the top. And then there's a beautiful ground-based telescope. Well, many amateurs have taken beautiful images too, so it was kind of fun because a lot of people contributed their images of the Horsehead as well. So it's a very famous amateur object, and it's also part of a very large extension of where the Orion Nebula is as well. So anyway, we decided that we had done the Horsehead in the visible before, and then we decided to try to do it in the infrared. And the team actually had a long, spanning many meetings, like over several weeks, of whether we were going to do the infrared or we were going to do the ultraviolet or what we were going to do. And in the end, we decided to do the infrared image. And it's so stunning that if you bring it up on your screen, the full image, it looks 3D. I mean, when you look at it, it's just amazing because you can see you can see right through it. You can see stars. You can see the structure. And then our animators made a 3D flight towards it, and it's a really nice image. It's just a stunning image. That's one that you want to print and put on your wall. So that's
very good one.
Very cool. So that's star formation.
Right.
So you got another one for us?
So there's another one which is I think is on your list, which is 5189, which was a 2012 image. And so the Horsehead is a star formation. Orion is star formation. This is what happens when a star like our Sun gives off its atmosphere. Now, in this case, a star like our Sun does not completely explode. It gives off part of its atmosphere. And the interesting thing is that early on it was thought that a star would do this once, but it turns out it does it more than once. And originally we thought that it would just be kind of either sort of elliptical in shape or spherical. Well, that's not what this is. This is a pretty interesting image because it's completely unexpected. So it kind of looks like, you know, when you go out in your garden and you turn on your garden hose and you forgot to, you know, clamp it down, and it just goes all over the place. So it sort of looks like from the center that there's some kind of jets and something that has like spewed off material in rings and in loops and in spirals, and then as that is all illuminated, it ionizes different chemical elements, and that's what gives it the color. But it's such a complicated structure, you can imagine. I mean, this is very hard to model.
Yeah.
And then as you look at it in more and more detail, you see, you know, it's not smooth at all. It's got all these nodules, and it streams outward, and it's weird.
It's very complicated.
Really weird, very complicated. But that's what can happen to a star. If it probably has magnetic fields. It's probably rotating, and as it loses the atmosphere, this is what happens, and then it ionizes.
There's a white dwarf in there somewhere, isn't there?
Somewhere in there's a white dwarf.
So this is how stars like the sun will die. Very beautiful, and we won't want to be around. I want to get a quick question in from Brad M. How long is it estimated will Hubble be able to be upgraded before it becomes obsolete? Hubble has gotten its last upgrade. It won't be getting upgraded anymore. That happened back in 2009. As far as becoming obsolete, I don't think that's possible. I think it'll always be usable as long as it stays up there. Now, if we do nothing to it, then its orbit will begin to go down, and around 2025, we'll have to start thinking about what we're going, what we're going to do with Hubble at that point. But that's a long way off, and right now Hubble's in great shape, taking great data, and like we said earlier, we want to be able to use it at the same time as JWST. So hopefully Hubble will still be around for a very long time. Okay.
So there are two more images that I really want to show. Well, there are several, but there is one. There's one that's called NGC 6302, and the other one is the Crab Nebula. So, I guess while we're talking about stars that explode, the image of the Crab Nebula would be fantastic to take a look at.
That represents an explosion that happened in 1054?
Yes.
Of a star.
So that explosion was actually visible by people who knew the sky very well, and so it exploded, and then nobody knew what it was until there were telescopes, and then the first telescopes began to understand that there was a nebula there, and then the observation with Hubble really demonstrated in detail. So
Scott, are you there?
Yeah, I'm here.
Oh, okay.
Okay.
I'm not sure if you heard. You having trouble finding it?
No,
there it is. No, there it is.
Okay.
That's great. Yeah. So this image is quite amazing, and we were talking about in the last case of the planetary nebula. In contrast, that one's pretty complicated, but this one's really complicated, and the reason that it has this really tortured structure, I don't know. It kind of looks like taffy that exploded or something. I don't know what, but it is magnetic fields that causes that ionized material to make that web-like structure. And so, some of it's compressed, some of it's spread out, and so in the explosion, these magnetic fields come out and they get all twisted up, and they trap the material, and then as the explosion then produces a lot of light, and that causes the material to glow again because it's ionized material, and the different colors of the different elements. But this is the kind of thing, like supernova explosions are interesting and studied because this is where the heavy elements, carbon, nitrogen, and oxygen, but all the other elements like silicon, plutonium, all that, iron,
star stuff.
Star stuff. And so they make that in their interiors, and then when these stars blow up, they spew that stuff back out into space. And as this nebula expands into material nearby, that stuff is compressed, and then you start getting new stars.
Right. This is the crucible of all that make us up. It's where it comes from. It's right there.
Right.
Okay, so go ahead.
Well, I was just going to say the next one we ought to look at, since we were talking about that, is NGC 3603.
Okay, while Scott pulls that up, I'm going to get to a quick question that I like the answer to this too. And will there be a chance? This is from Cesar E. from the Q&A. Will there be a chance that Hubble makes pictures of the remains of Eagle, the Eagle lander, the Moon rover, etc., on the surface of the Moon? Carol, do we ever have any plans to look at the Moon with Hubble to see those things?
No, the Moon is too bright to do that, but there has been observation. And remember, Hubble is a science instrument. There have been flybys and other telescopes that have already imaged those things. There's lunar reconnaissance orbiter and things like that. I mean, those LRO takes pictures of the surface all over the place. So
yeah, LRO.
There are satellites there that are taking much better resolution. There were some observations of the Moon near the terminator to look for the possibility of evidence of water, which was not found. But that's one observation. And then Mars, we've mostly done. We've done looking at the weather, but we can't actually resolve the actual landers. But there are orbiters around Mars, like we have Landsat and GOI and stuff like that go around our own planet. We have satellites that go around Mars that have great resolution for finding that stuff, and they have found.
Uh-oh. Hello?
Yeah, I'm here.
The landers and bounce around in their pillows, and those have been found and all that. So those images are quite spectacular. But no, we're mainly we do science instrument science studies only. We don't do.
Yeah, that's a common question. Good
NASA.
one, Cesar. Thank you for asking that. Scott, how are we doing on the? Are you able to find what she was asking for?
I was just
3603.
Okay, yep. Let me pull it up here.
Yeah. Now, so what we were talking about before, when we talked about the Crab Nebula, so we've seen star formation regions, and we saw nebula like the sun blow up, and we have also seen, or they are more puff balls, but quite dynamic. And then Crab Nebula, so we have supernova that blow up. And in this case, this is the material. So there was a material that came from those early stars that blew up, and all that stuff mixed together, and it collapsed, and it made this star cluster. And so this star cluster, it's a bunch of stars that have formed together. I just think it's quite beautiful. There's hundreds of stars that have formed together, and it is emerging from the material out of which it was born. So in Orion, we can't see these star clusters yet because they're still embedded. But here's a case where there's a nebula where it is old enough that the ionizing radiation from the stars in the cluster has pushed that material away, and you can see that it's sculpted things away, and it's pushing it out and pushing material into some material into the material that was already there. So I think the emerging clusters are really of interest to me, and I really like this cluster.
They're also among the most beautiful images too that Hubble's ever taken. I think this is amazing.
Yeah.
Right. Now, to illustrate a similar point, another cluster that we looked at was the Tarantula Nebula.
Okay.
The Tarantula is in it. Go ahead. Did you have a question?
Are you pulling that up, Scott? I was wondering.
Yeah.
Okay. All right. So go ahead. Well, let's wait till he gets it up before you talk about it.
I just wondered if you had a question.
But the reason I say that it's a good opportunity for you to get to. We've got a lot of questions. You guys are really doing great. Thank you so much for sending all these.
Okay. Yeah. Let's have another question.
Yeah. So Tony Lynch is asking. This might sound like a wacky idea. Would it have been possible or even feasible to lower the HST's orbit and attach it to the ISS? it's a good idea. And when John Grunsfeld left on the last servicing mission, when he left Hubble in orbit, he attached a black ring around the bottom of the telescope. And if you look at some of the pictures of the Hubble in space, you can see it there. So in theory, it's possible to send up maybe a SpaceX robotic satellite or something that can grab it and pull it down.
But we do not want to do that because the ISSs are really crappy environment.
That's what I was getting to. Why would we want to?
We don't want to do that. I understand. Yeah, you could have it right next door and you could change the instrumentation, but then you really compromise the integrity of, first of all, the cleanliness of the instrumentation. So there's contamination from the ISS, and secondly, you can get stuff on the mirror, and so it's much better to have Hubble isolated. Away from the atmosphere, so that's why it's so high, because there is still a little bit of atmosphere up there, and we don't want it in a dirty environment. And there have been many cases, there have been several proposals of putting demonstrator telescopes tethered to the ISS, but it is well understood by the astronomical community that if you put a facility up there, it will be very dirty.
Right.
That it will not have beautiful image quality, and you will compromise your instruments over some period of time.
But I think the spirit of the question was, could we maybe do that, bring it down to ISS, repair it, and then move it back up again? But that would be...
Oh, no, and the reason that's a lot of work, and it can't be moved because the solar panels are deployed, and there's no way to fold them up. You can't, and you can't fold the antenna and all that. It went up in the shuttle. That was the perfect transport mechanism. But once deployed, it was meant to be deployed. You can't fold it all up, and you'll damage it and get it dirty and all that stuff. So, yeah, interesting idea.
Yeah, interesting idea, though. Okay, Scott, do you have it up here?
I do.
Okay.
So the tarantula is interesting because, so thinking about 3603, which was, we saw one cluster, this is a case where it looks like there's an emerging star cluster kind of on the leftish side, but it does appear that in the detailed studies that star cluster then spawned. Notice that there's one on the left but up near the top, that these clusters are forming all over this region, but the presence of one cluster is illuminating and pushing the material out of which it was born, causing it to run into other material, and then another cluster is formed. And so it's believed, people who are studying this very carefully are looking at how many generations of star clusters are in this region. And so it's pretty interesting because we don't have another good example. This is in a companion galaxy, one of the Magellanic Clouds, and because it's far enough away, we can see the whole region, and we can see these multiple generations of star clusters. And this is not just one Hubble image. This is a Hubble mosaic. So it's like using panorama or whatever with your cell phone. So, that's how we do it.
And the biggest example of that we have is the Andromeda image that was released in January called the FAT image, and that was a 300 megapixel mosaic of all kinds of Hubble pointings, and so that's another really great image that went in there. Okay, I have a request now. I want to see a deep field. Would you find the latest deep field?
Oh, you're so impatient. We're so impatient.
I know.
We're running out of time, and we have so many
going
questions.
off script, but you're like, give it to me now. Like,
well, I want to talk.
No, that's fine.
We don't have time.
Can look at the Hubble deep field. All right, we'll do it in the deep field.
Okay, so here's a question from Julian O. Moonspell from YouTube. When Hubble Space Telescope takes an image, let's say the Orion Nebula, does it give a color image, or do you have to process it and assign colors? What is the convention for this? Basically, it does not take color images. What you see when we get back from Hubble are a bunch of grayscale images, all taken with different filters of different wavelengths, and then they're assembled according to those wavelengths. They're assigned a color table, and that's where the color comes from. That's a very short answer to your question, but I wanted to give you the convention is basically Hubble has many filters, and when it takes an image in that filter, all it's got is a file with pixels and numbers in it, and those numbers represent how much of that light, how many photons there were, and so it'll be different in red as it would be in blue or green. And Hubble has, gosh, I don't know, how many filters does it have, Carol?
I don't know. It's got
That's a
100
bunch.
filters.
And there has a bunch.
Because each instrument has several filters.
But an interesting note on that, though, is Hubble is the only space telescope that has filters in the ultraviolet. So if you want anything in the ultraviolet, which is important for star formation studies and things like that, Hubble is the only game in town.
So I wanted to comment that while this beautiful picture, it gives you an impression of the astrophysics happening here, in order to actually understand it, we need those filtered images. We need to look at and measure, because we can't measure this. This doesn't tell you how much is emitting in oxygen and carbon and nitrogen. And we also need to measure the stars at different band passes, at different energies, to understand how old they are, how big they are, all that. So we need the individual filters so that we can understand in detail how the stars, what they're made of, and how old they are, and for the nebula, exactly what the chemical composition is of the nebula. So where is the oxygen relative to the nitrogen? So you need to use a nitrogen filter and just look at the nitrogen, using the oxygen filter just to look at the oxygen, and then you can understand the relative relationship of those different components in these nebula. So that's why we take the different. We make the pretty pictures because they're pretty and they're interesting and they inform the science, but that's not what, they're not the heart of what scientists measure.
Okay, here it is, folks.
Actually, that's not it. I lied to you. That's an old one.
You tease me.
So that's an old one. Okay.
There's so many ultra deep fields.
I know.
Let's pull this up.
Yeah.
The one from.
My favorite is still the first one, the one from 1995. But another question then while we're waiting. Would you ever consider attaching propulsion to Hubble to send it further out into the solar system to possibly get better images as it moves out, or gets newer viewpoints, or possibly to other outer solar system to better see what is in dark areas of? Would I consider it? Sure. Will I ever? Is it practical? I don't think so. I think leaving Hubble where it is probably the best way to go there for that. Any comments on that, Carol?
Well, okay, Hubble was not built for that. If you're going to do that kind of thing, you have to think about how your antennas are going to work, how strong the antennas are going to be, whether they have sufficient power to do that, whether you can control it. You have to send signals, and the further out you go, the more time lag there is when you're pointing the telescope. So there are a lot of considerations, and so that's why the telescopes that go out into the solar system are very specialized. They have specific equipment to do the job they're supposed to do, and they have transmitters and antennas to receive commands and transmitters to transmit back information that are specific to that. And Hubble was never built for that. So and the other thing is, although Hubble has been boosted slightly, its solar panels are so fragile that you can't just be moving it around. So the process of moving Hubble is a very delicate thing, and the astronauts have done that. They've done it. They've boosted with the shuttle. They've moved it out slightly, but it's this stuff is very delicate, precise, and you can really mess things up by putting a propulsion system on it.
Yeah, that's a way better answer.
It was never built for that.
That's a way better. Yeah, that's a way better answer than the one I was going to, my flip answer that I gave you. So thank you, Carol. Okay, Scott, thank you for putting this up. Here it is, folks. This is my favorite image ever. The image itself, while it's pretty and there's a bunch of smudges and smears everywhere, the thing about this image that gets me every time is how it was taken and what it represents. This was taken in an area of sky where we didn't know that anything was there. It was a dark area. There were no stars in our galaxy. There were no other galaxies we knew of in the way. This was a black patch of sky where nothing was ever thought to be. And when they exposed the telescope, they saw a frame filled with galaxies. There's 11,000 galaxies or so in here. And we've revisited this sky this place many times. Most recently last year, I think, where we looked at it in the ultraviolet, and we added ultraviolet wavelengths, and we saw a few more galaxies and things like that. And this to me is still the most important image ever taken. And I don't know, Carol, do you want to add some actual science comments to that instead of a bunch of fluff that I just did?
Okay, so the reason that the importance of doing deep fields, first of all, you will, of course, want to push as deep as you can back further and further in time. And the idea is, one of the ideas is, can you see galaxies forming way back? So number one, so can you count them and measure them? So that's the first task, and you need multiple filters to do that, because we cannot use spectroscopy to determine that. The faintest objects here cannot be reached using spectroscopy, so we need to take images and filters to guess at their distances. The other question is, so there's the distribution in space going outwards from the Earth, and the other question that one wants to ask is, you see morphologies of, you know, the spirals, ellipticals of nearby galaxies. Is the same thing happening? How far back is the same thing happening? And how were galaxies first formed? Were they small little pieces that ran into together, or are large galaxies formed as large galaxies? Did they start out as large galaxies and they're always like that, or what? And it turns out it's likely that galaxies actually form from small bits and pieces, although curiously enough, there are some, when you look back in time to the early universe, there are some very massive galaxies even back then. So there may have been pockets of material that formed very large galaxies, and in other places, little ones that later merge and form galaxies.
And let me just remind you guys that we did a hangout with Massimo Stiavelli a couple of weeks ago where we talked about the earliest galaxies and their first stars. So he gave us a lot of good information on that as well. Judy Schmidt, hi Judy. The solar panels are not attached very strongly to the telescope? Question mark. Apparently they are.
They are robustly attached to the telescope, but they are large extended pieces of mylar.
Right.
So take a huge piece of mylar and, you know, leave it out in space, and it's going to flop. As a telescope, I mean, there's a little bit of atmosphere up there, and so it is going to be affected by that. And so they move, and in fact, they were replaced by smaller solar panels because the large ones had some problems. So solar panels are an interesting technology, and if you're going to have the stretched out, lightweight, so you can launch it, yeah, they're robustly attached to the telescope, but you can't be just shoving them around in space.
Oh, yeah, and especially
they're very delicate.
They're built for being in low Earth orbit and maintaining that. So if you're attaching it to another spacecraft and putting that sort of force onto it by just the acceleration, it's not. Right. It wasn't built to be on there.
It wasn't built to do that.
From an engineering point of view, it's not meant to be receiving as a force. Right.
It's not a G. So I am compelled to show, because we, you know, preempted my story. I would like to show the Galaxy M83, which is an and there's a point there. Okay, two more things I want to show. One is M83.
You know we have email before the show, right? I'm just making sure.
We'll talk about this, okay?
All right. Okay. So while we get our ducks in a row there, Tiberius Maximus. That's a great.
Yeah, right.
What amazing breakthrough is it that it makes astronomers most excited for 2015? I don't know, Carol. Are you looking forward to anything this year? Me, it's Frontier Fields. I like watching all this.
Frontier Fields, I think. Frontier Fields, but you know, I don't like choosing the best. There all
because you choose me all the time. I mean.
Yeah.
Oh yeah, so, we'd all just choose Scott.
Let's not go there, but you know, everyone, you know, exoplanets, planets. There's all kinds of things going on that is research, and all of it's spectacular.
Yeah,
and
exoplanet
so I can't choose the best because
I
believe that all these lines of investigation, and they're all also connected. So So, and I want to try to sell that story to you because we have talked about the Orion Nebula, we've talked about supernova exploding and pushing material into other materials, forming star clusters like 3603 and the Tarantula Nebula. And here's a galaxy that we're looking at, and this kind of thing is going on all over this galaxy. I mean, there's all kinds of star formation regions. There's one cluster, you know, you can see over kind of in the mid-left. There's a bubble, a cluster with a bubble. Exactly that's what's happening, only it's a distant galaxy. And so that star cluster is pushing its material out. It's running into that other material, and there's going to be new star clusters forming.
Look at that.
And so it was, you know, the whole part of the story, and this is considered, even though this galaxy is pretty far away, in the cosmic scale, this is a quote a nearby galaxy, and we can see the star clusters, and we can count them. And we can see how they're related to the overall spiral structure. And so the next step of the story was, well, although there's an intermediate step, because I want to ask you to show another image. The question about the HDF is, okay, we see these spiral galaxies and elliptical galaxies. Is that what's going on in the distant universe? And that was the point of doing the Hubble deep fields, is to find out if galaxies like we see today are forming in the early universe. And it looks like pretty far back they are. But then at some point, this grand design type of formation was not happening, and it probably was built up from little tiny pieces. So the last one, which you have on your list, is R273.
All right, let me pull it up.
And this is another piece of the puzzle. So there's three galaxies here. There's the large spiral galaxy you see. There's one below, and then up on the right quadrant, there's another galaxy. And so part of the clue of this happening with the star formation being triggered all over a galaxy is that there are many galaxies that interact and produce these spiral patterns and produce all this star formation. And it's a lucky thing, because we wouldn't be here without supernova and star formation and exoplanets and all that. So it is a thread, and that's why it's hard for me to choose one thing, because these things are all related. And
right.
We need to understand every piece of this to actually understand the whole universe that we're in.
Very good. Okay.
Ta-da!
So you got them through. All right. We've got 3 minutes and a bunch of questions.
Oh my God! All right.
I want to give one to Luca Skywalker from YouTube. I have a question because it is quite confusing. With naked eyes, we cannot see a real nebula how it looks, right? We need the same filter that the Hubble telescope has, but actually how it looks like out there without. So what does it look like without any filters? Are there any real images? In other words, I think the spirit of this question is we're kind of not looking at this thing like it really is. If we looked up at the sky with our own eyes and tried to see this nebula, that's
a question that's always asked. And amateurs take pictures all the time without filters.
Especially like the Orion is a perfect example of that.
Right, that's an example, but it isn't as rich because your eye cannot respond to all of the wavelengths, and it cannot discriminate between the carbon, the nitrogen, the oxygen, or what the colors of the stars are. So for science, we take images in different colors, not for the glory of making pretty pictures, but to do science, and we need the filters to do robust science. And so we make the color images to demonstrate the astrophysics, but the real measurements come from the individual frames. So if you just go out in space, you will not see the same dynamic range. Things will just look kind of gray. They usually are not very. When you look up at the night sky, there are a couple stars that you can see that have color, like Rigel and Betelgeuse, and you can tell that if you're careful, you can tell that Mars is reddish. But we don't have the same discrimination and dynamic range in our eyes. And so if we just showed you the composite images, you'd go, huh, okay, kind of interesting. But even Hubble has much more dynamic range and both wavelength coverage and dynamic range. So it doesn't really represent what the eye would see. It's much richer than that because that's what we need for the science.
Okay, well, I guess we will leave it there. Thank you, Carol, and thank you for that question. That was a good one. And gosh, you guys, this has been a fun hangout. You guys were really active. Thank you for leaving us questions and comments, and I tried to get to as many as I could. So I'm sorry if I didn't get to all of them, but we've run out of time. Before I sign off,
I do want to make one note here, just from Twitter. Monique Jacob just says, like, every time I think Hubble can't impress me any further, they release another stunning picture that makes me speechless.
That's great.
I agree. Even being someone on the inside, the same thing goes. Whenever I see something new that's coming out, like, what? How? Okay. I get to be excited all the time about the new things that were going on. The altered deep field with UV, the Andromeda one, or the smiley face. I thought that was an amazing.
Yeah, that was a very popular image. That was a very popular image.
It got a lot of great. Got a lot of people talking about it, and understanding what an Einstein ring is, and how it really digs into things like frontier fields and understanding gravitational lensing. And so I think it's great that not only is it beautiful, but we can learn so much from it in the same process.
Absolutely.
Much more to come. So on that very positive note, we're going to close our hangout. I want to remind everybody there is an Ode to Hubble video contest going on right now at ESA, at esaspacetoLescope.org. I have the link also in the description box, so go and check it out and leave a video, make a video about telling us some of these things, like what Scott just read from Twitter. So we'd like to see your video, so don't forget to do that. Next week's hangout on Thursday at 3 o'clock, we're going to be looking at the granddaddy of all debris disks, Beta Pictoris. And we've got a lot of it. We've got a press release coming out on Thursday about this. We'll have the principal investigators announcing some new research from Hubble on all you wanted to know about debris disks. So we hope we'll see you there. Thank you all for watching. This has been one of the funnest ones we've ever done. Thank you all so much. And on behalf of Carol and Scott, keep looking up.
Looking up. Thank you.
The image. Now, we did unveil an image at the AAS, but that was not the image. And are these past Hubble anniversary images, Carol?
Some of them are.
Okay.
Some of them are. Not all, but some are, yeah.
Okay, so that's where we've gathered a lot of those up. There's some videos that are being created. One of our video producers in-house every month is going to be producing a Hubble-themed video. And the first one is already created. It's called The Beginning. And you can watch them here. They're also posted on our YouTube page, our YouTube channel. The next one should be out this month soon. So the idea is to put them out once per month. Is it for every month of the year, or just leading up to the anniversary, Carol?
Leading up to the anniversary, and I mean, she's really uncovered some interesting information, but also some interesting people. And she found somebody who's very old, but she found him, and he knew Hubble.
So, that'll be great.
So she did get an interview with him. He's like 95 or something. Anyway, she has interviewed some really interesting people in connection with this. She's done a wonderful job on these videos. They're really,
she really has. They're awesome.
So.
And who we're talking about is Maria Stacion. She also does Behind the Web. That's another video series that she's also doing. So so look there to see about all the videos will be posted here as well. There's an Explorer section. These are resources, I guess, we got for students and educators. So if you're a teacher and or just a regular, we'll take you to Hubble site. So it's a link that goes to Hubble site, and you can read about some of the articles that we have there. So there's a lot. We're going to try and really be as thorough as we can, because there's so much Hubble stuff that you can learn about everything going on and what Hubble has done in the various areas. Now, in the terms of extrasolar planets, though, Carol, this is a pretty new area in which Hubble's been contributing, isn't it?
It is, and it wasn't really foreseen that Hubble would produce as much as it did. And the interesting thing is that even before Kepler was launched, Hubble had done a transit. It has looked, of course, famously at the debris disks, and still looking at debris disks from a couple of famous cases, but also there's a lot more going on, getting data from the archive and really picking through it and finding out all the details of debris disks, and then trying to understand the relationship between debris disks and planet formation. And then there have been a few studies of actually atmospheres. So that's a little bit of a preview to what James Webb will be able to do on extrasolar planets, and of course is related to things that other orbiting and ground-based telescopes do regarding extrasolar planets. So
right. So yeah, and so that's just so this is where most of the science will be highlighted. That's the science tab, so you can check all that out. The images area. In April, we're going to be unveiling the actual Hubble anniversary. Hello, everybody, and welcome to this week's Hubble Hangout. My name is Tony Darnell. I work at the Space Telescope Science Institute, and we have a really great hangout planned for you today. We're going to continue our celebration of the 25 years of Hubble Space Telescope being in orbit, and we are going to show you what we're calling the microsite, which is sort of the central hub of all things Hubble 25. And we're also going to show you 25 of what we consider to be some of the most representative images of not just the science of Hubble, but also some of the images that illustrate some of the beauty of the universe as well. And so with me to talk about that is, as they are with me every week, is Dr. Carol Christian. She's the outreach scientist, and Scott Lewis, Esquire, the third Esquire.
Wow. Every week it keeps going. I love this.
Yeah.
I just call me the Lord of the Internet, and that's fine. No, I'm from knowthecosmos.com.
And from knowthecosmos.com. So this week's format's a little bit different because it's just going to be the three of us talking about these things. So we really want you. This is a great chance for you to ask us questions, leave us comments. The best way to do that's with the Q&A app on Google Plus or the video that you're watching this on. I think it's also on YouTube as well. And you can comment on the YouTube channel this is being broadcast on, as well as the Google Plus event page. We're looking at all these things. So I'm already seeing Tony Lynch giving us a hi and Michael Jobin giving us an exclamation point. So keep them coming, folks, and we'll get to them as we step through the program. So let's get started. So Carol, we are in the process of celebrating the 25 years of the Hubble Space Telescope. And we made this thing called the microsite. Let me share my screen and put it up.
Let's show that.
You get to this thing by going to Hubble 25th.
Fifth.
That's so strange.
25th.
Yeah, Hubble25th.org, and this is where we are putting everything that all of our content will be highlighted here on this spot. So it's relatively new. We just went live at the AAS in January, so it's been up about a month and a little bit longer. Mm-hmm. And as you can see, it's right now. I've got a big banner up here. We've got some things along the side that we're going to get to each one of these. But if you're interested in finding out about news, things that are coming up, this is where you would go. On March 7th, there's going to be a symphony orchestra concert in Baltimore. So all of these things are going to be listed here. Our hangout from today is right up here as well. So you would have learned about our hangout from here if you don't subscribe to our stuff. So these are some of the things. And down at the bottom, we have our Flickr stream, and I'm going to come back to this because that's going to be the highlight of most of what we talk about. And then below that, a little bit about the mission itself, right? Just a brief summary of what Hubble is and how it was deployed and when it was launched and all that kind of stuff. And then we have these other things across the top here. We got a tab called Science, and when you click on that, what do you see, Carol? What is this page designed for?
So this page talks about the basic topics of that Hubble covers, and some people are surprised that we actually do solar system science, but we do. And I think everybody knows we do extrasolar planets, and then bread and butter is stars and nebula, galaxies, and then of course the universe. So we cover all of those topics. From the ultraviolet to the infrared, and this is just to introduce the user to some of the science topics that have been covered, highlights of the science topics that have been covered. I knew some of the solar system science, but actually at the AAS we talked through that, and Hubble has really done some exciting things, which it's hard to observe solar system objects with Hubble. It's tricky, but we've done some interesting things. So
some of our biggest hangouts have been on these topics too.
Yeah.
just last week.
Like the Jupiter, yeah.
Yeah. So, and down at the bottom there are links also. There's going to be articles as throughout the year as either new press releases come out or new stories come out. So you want to check with these different sections. If you click on some of these links, like this comet ISON breakup.